Logarithmic Equations Part 2. So this is a little bit more complicated equation than the one presented in Part 1 video. So if you remember from the previous exercise, our goal was to obtain an equation that would have logarithms on both sides, and both logarithms would have the same base. So to base A, C, so just I'm going to recall the conclusion that you always can draw. So when you have the same logarithms equated, then the value inside of each logarithm must also be equal. So in order to achieve that in this exercise, we have to combine these two logarithms using the rule, the product rule. So log to base 10 of 2 times x minus 3. Or you can say x minus 3 times 2, but in written form, we're going to show it like so. On the left side is log to base 10 x minus 1. So the product rule here, I'm going to quickly show you log AB plus log to base AC is equal to log to base A of B times C. So this is another blur that we have to be aware of. So at this point, we will drop the logarithm on both sides and create the following equation. X minus 2 is equal to 2 times x minus 3. So let us solve this equation for x. So distributive log, so 2x minus 6, you multiply 2 times x, 2 times negative 3, bring everything to one side that contains x. So let us keep x is on the right hand side for now. So 2x minus x, and on the left side I have already negative 1, move negative 6, so plus 6. So I have x on that side and 5. So therefore it seems like the value of x is 5. Does it really work in this case? Restrictions. X minus 1 has to be greater than 0. So this is what we need to check. And x minus 3 must be greater than 0. So whatever value you're going to use for x needs to generate positive number. And it will, because 5 minus 1 is positive, and 5 minus 3 is also a positive number. So this is the correct solution to our equation. Now, another equation. We have 3 logarithms, 2 on one side, 1 on the opposite side. They all are to base 10. So what we can do, we can apply the product rule to simplify the left-hand side. So you will see log, and then you multiply x minus 3 binomial times x minus 1. So let's do it like so, times x minus 1. And the right-hand side remains unchanged. So if you recall the rule from the previous exercise, now we can drop logarithm and create this equation that reminds us of a quadratic equation. So in order to solve this equation now, we're going to have to expand it. So x times x, x squared. X times negative 1, so minus x. Negative 3 times x, minus 3x. Negative 3 times negative 1, plus 3. Bring this one over to the other side, so take away 1. set it equal to 0. Okay. Simplify. So x squared is by itself. Linear terms, -1 and -3 minus 4x. 3 take away 1 plus 2, and this is beautiful quadratic equation. Now, we may wish to attempt solving by factoring or simply by using quadratic formula. So, since I can see whether this is factorable or not, I will attempt to use the quadratic formula, which looks like that. -b plus or minus the discriminant, b squared minus 4ac, everything is divided by 2a. So a is 1, because this is the coefficient in front of x squared. B is equal to -4. That's the middle guy. C is the constant value, equals 2. So by replacing letters A, B, C's with the values that are given in our equation, we can further solve it for x. So 4 is -b plus or minus square root. Now b squared, so -4 squared is 16. Whoops, I meant to say 16. I better stick with that. So 16 minus 4 times a times c. So 4 times 1 times 2, 8. Wonderful. Divided by 2 times a divided by 2. So 4 plus or minus 16 minus 8, 8. So square root 8 divided by 2. So our job is now to simplify. So before we do that, quick recall of the following. Square root 8 further can be written as square root 4 times 2. And when you split into two radicals, radical 4 times radical 2, you'll see 2 root 2. So this is what we will use to simplify our equation. So let's go back. X is, now, so let me draw the little, so x is equals 4 minus 2 root 2 over 2, or x is equal to 4 plus 2 square root 2 divided by 2. Now we can divide this expression by 2, so you'll see x is equal 2 divided by 2 is 2 minus root 2. The second value of x is 2 plus root 2. The declaration now, which root is acceptable, both 1 or none. Quickly, let us go back to the beginning of this equation. X minus 3, remember, has to be greater than 0. X minus 1 has to be greater than 0. So this gives you the idea now that x has to be greater than 3 and x has to be greater than 1. So remember, x is greater than 3 and x is greater than 1. So the sharing begins from values that are greater than 3. So you can only use the value of x that is greater than 3. So 2 minus square root 2, nah, this one is too little. 2 minus square root 2, it's about 0.6 or 0.5 in that range, so definitely not included. 2 plus root 2, greater than 3, so yes, This is the guy that will be the only solution to that equation. So, I hope you enjoyed this video. Thank you very much, and I see you next time.